So what I was saying, these photons are coming with energy 5. With energy 5. If it comes with energy 5, it won't be, won't be able to take out the electron from the surface of the metal. Certainly not. Now I'm increasing the energy. I'm increasing the energy from 5 to 6. Still it is not going. From 6 to 7 to 8 to 9 to 10. Now it is 10. These electrons are bonded with the metal with a force of 10, and I am supplying some energy with 10. Please understand it. I am just showing it with something over here. It's very difficult. Suppose this pen, all of you can see me, this pen, and the cap is there. Cap is bonded with the pen with some force. With some force, okay? Now suppose this force is 10. The force by which it is bonded, by which it is locked is 10. Now I want to open it. I want to take it out. Clear? I am applying some force. But that force is less than whatever force it is bonded with. It won't come out. Now I am applying the equal force. As I applied the equal force, it just came out. It is loosened now. This cap is now loosened. Okay? But just loosened. Okay? So it was 10. I applied 10. It is loosened. It is now no more bonded with the pen. No more bonded with the pen. Now if I apply some more force, means suppose 12 or 15, if I apply 12 or 15, what will happen? It will start moving. It will start moving. The cap will start moving. Did you understand that? That's the concept. That's the concept simply. The force was there. I am applying a minimum force which is just loosening up the electron from the metal surface. If I apply more amount of force, it will just come out and will start moving. And as the electron starts moving, the electricity will generate. And if the electricity generates, then the voltmeter will deflect. Is it clear? Okay. So that is what I am saying. So if the amount of energy is 10 now, if the amount of energy is 10, then the electron is just loosened up over here. It's not moving. It's not moving. But if I increase it to 12, suppose, if I increase it to 12, out of 12, 10 will be required to loosen it up. 10 will be required to loosen it up from the surface. And the remaining energy, that is 2, will be make it to move, means 2 will be converted into its kinetic energy. Yes? Did you get it? So what is it? That is what is the photoelectric effects mathematical expression, and this can be explained by the concept of photon. A photon is a particle. It is hitting the metal surface and taking out the electron if the photon has got the sufficient energy. Okay, and then if it has got more than that, that electron is moving. Suppose anything, this pen is here. If I hit it with some force, if the particles, any particle hits it with a force, it is bonded with my left hand. If I hit it with some force, it is not moving but it is loosened up. If I hit it with more force, then what will happen? It will start moving. It will start moving means it will generate the electricity. The electron will start moving. So what can we say? That energy of photon, okay, that is 12 here, whatever example I have taken, is equal to what? Is equal to the energy that is required to loosen up the electron, 10, okay, that is energy. I'm just writing in words first, then we will write the actual one. Energy to loosen up the electron, okay, plus what is this 2? With this 2 the electron is moving. With this 2 energy the electron is moving, and that is nothing but the kinetic energy. That is nothing but kinetic energy. That is the mathematical expression of what? That is the mathematical expression of photoelectric effect. So what can we write over here? You see, what can we write? We can write energy of photon. Now mathematically we can write energy of photon, that is E, okay, is equal to some energy, some minimum energy which is required to take out the electron from the metal surface. That minimum energy is represented by E0. We write it by E0, and this particular energy is called threshold energy. Is called threshold energy. Okay, so what is threshold energy? The minimum energy of a photon required to just loosen up the electron from the metal surface. Okay, metal surface से loosen up करने के लिए minimum whatever energy is required, that particular energy is called what? That particular energy is called the threshold energy. Yes. Okay, so E0 is threshold energy plus the kinetic energy. What is that? I am writing over here, kinetic energy. This is the mathematical expression of the photoelectric effect. Now what is E? What is E? E is nothing but the energy of a photon. An energy of a photon we denote it by, in another form we denote it by h nu, where nu is the frequency of the photon, h is the Planck's constant. This is equal to what? This is threshold energy. That means if we increase the frequency, one frequency will come when the energy will reach E0. That is denoted by, according to Planck's equation, we denote it by nu 0, h nu 0. Nu 0 is what? Nu 0 is the minimum frequency of the photon, which is responsible for taking out the electron or just loosen up the electron. This minimum frequency is called threshold frequency. This is called threshold frequency. Threshold frequency plus kinetic energy. What is kinetic energy? Half into mv square. What is m? What is moving? Electron is moving, right? What is moving? Electron is moving. So m is what? M is nothing but mass of electron. M is nothing but mass of electron, and v is the velocity of the electron by which it is moving. Okay, fine. One more thing, this threshold energy is also called, one more term, the threshold energy is also called work function. This is also known as work function. And this equation, in terms of lambda, if we want to write, we can write nu 0, or you can write h c by lambda. Everything we just convert it to lambda. What is the relationship between nu and lambda? We know nu is equal to c by lambda. So h into c by lambda should be equal to h into c by lambda 0. What is lambda 0 now? Maximum wavelength. Minimum frequency means maximum wavelength. Maximum wavelength where the electron is loosened up. Plus half mv square. So whichever way you write, the same equation only we are writing. Okay, and that is what is known as the photoelectric effect equation. Now we are going to solve one numerical, and I am going to give two. I think we have enough time. Yes, we have got enough time. So we have to solve one equation, and solve one numerical, and I am going to give two more for your homework. So first one you write the first one. I am just dictating it. First you write this one. In a photoelectric experiment, a metal was exposed to a EMR. A metal was exposed to an EMR. EMR means electromagnetic radiation of frequency. The value is 5.2 into 10 to the power 14. 5.2 into 10 to the power 14 second inverse, or you can write hertz also. Okay, yields electron with kinetic energy. Yields electron with kinetic energy. The value is 1.3 into 10 to the power minus 19. 1.3 into 10 to the power minus 19 joule. Okay, 1.3 into 10 to the power minus 19 joule. Calculate the threshold frequency. Calculate the threshold frequency of the metal. Calculate the threshold frequency of the metal. First thing, you read the question nicely. First of all, you read it nicely. Note it down, read it nicely. Then we will solve it. Simple one. Only one equation is needed, nothing else is there. It's just a very simple one. Yes? Threshold frequency means the minimum frequency that is responsible to just take out the electron from the metal surface. Threshold frequency means the minimum frequency that is required to just take out the electron from the metal surface. Okay, minimum frequency. Okay, so what is there? A photoelectric experiment, a metal was exposed to an electromagnetic radiation of frequency 5.2 into 10 to the power 14. Means the frequency of the photon, that is nu, is equal to 5.2 into 10 to the power minus 14 second inverse. Yes, that is nu. Yields an electron with kinetic energy. Kinetic energy of the electron given is equal to 1.3 into 10 to the power minus 19 joule. Okay, I'm just framing the question. That is what every time I say, I call it framing. Calculate the threshold frequency of the metal. So we have to find out nu 0, right? We have to find out nu 0. That is the threshold frequency of the metal. Is this the question? That's the question first of all. And we had understood that this question is related to the photoelectric effect. This is related to the photoelectric effect. Now what do we know? What is the photoelectric effect equation? We know that E is equal to E0 plus kinetic energy, or we can write H nu equal to H nu 0 plus kinetic energy. Simple one, see, it's very simple. So you know nu, the value of H is supposed to be known. As I told, this is a constant, Planck's constant, and we all should know the value. The value of this is how much? 6.625 into 10 to the power minus 34 joule second. Okay, so the unit is also perfect. It's given in joule and it's given in second, so you don't have to change the unit. So can we find out H nu? We can find out H nu very easily. Okay, we know the kinetic energy. We know H nu, we know kinetic energy. We can find out H nu 0 from there. As we know H nu 0, since we know the value of H, we can find out the value of nu 0. So let's do it. Let's do it. What is that? So H nu is what? H is 6.625. Let me just write it down. 6.625 into 10 to the power minus 34 into, what is the value of nu? It's 5.2. 5.2 into 10 to the power minus 4 or minus 14. It was 10 to the power minus 14, not minus 4. 10 to the power minus 14. 10 to the power minus 14. Okay, so that is H nu should be equal to H nu 0. Again I am writing 6. H already we know. 6.625 into 10 to the power minus 34 into nu 0. Yes, plus kinetic energy. What is the kinetic energy? The value is already given. The kinetic energy's value is 1.3 into 10 to the power minus 19. Okay, so can I write now this value, let us keep in one side, and other two we will bring in one side. So I can write it as 6.625 into 10 to the power minus 34 into nu 0 equal to 6.625 into 10 to the power minus 34 into 5.2 into 10 to the power minus 14 minus 1.3 into 10 to the power minus 19. Can I write it? Can I write it? Just rearranging it. It's nothing. I'm just rearranging it. कुछ नहीं कर रहा हूँ. Just rearrange. It's just rearranged. Now let's calculate this value. Let's calculate this value. What is this? 6.625 into 5.2. Do it. How much is coming? Tell me. 6.625 into 5.2. So that is 10, 2 to the 4 and 1 5, 6 to the 12, 6 to the 12 and 1 13 into 5 5 is 25, 5 to the 10, 10 and 2 that is 12, 5 6 is 30, 30 and 1 31, 5 6 is 30. Okay, so that is equal to 0 0 5 4 1 3 1 2 3 4 1 2 3, 4. 31.45, 31.45, right? That is equal to 31.45 into 10 to the power minus 34 into 10 to the power minus 10 to the power minus 34, 10 to the power 14. This is right. This is not. This is 14, not minus. That is plus 14. Okay. 10 to the power 14. 10 to the power minus 34 plus 10 to the power 14. So that is equal to 10 to the power minus 20. 10 to the power minus 20 minus 1.3 into 10 to the power minus 19. Minus 1.3 into 10 to the power minus 19. Now, while doing the subtraction like this, some non-mathematics students are there, that is why I am saying this. While doing the subtraction like this, we have to make the power same. Power same. Either you make it 20 or you make it 19. Whatever way you want to do. So if we make it 19, it will be how much? 10 to the power minus 19 means it will be multiplied by 10. So it will be how much? It will be 3.145 into 10 to the power minus 19. 3.145 into 10 to the power minus 19. Or if you want to make it 20, you can make it as 20 also. That will be 13 into 10 to the power minus 20. So whatever you make. So that is equal to, okay, let me make it 31.45 into 10 to the power minus 20 minus 13 into 10 to the power minus 20. Yes, 13 into 10 to the power minus 20. So what we did, we just made the power same. Nothing else, we just made the power same. Now we just calculate it, how much is coming. So that is equal to 31. This is common, right? 31.45 minus 13 into 10 to the power minus 20. So 31.45 minus 13 is equal to how much? You just calculate it. How much is coming? It is 18.45. Coming to not? Coming as 18.45 into 10 to the power minus 20. That is what? That is 6.625 into 10 to the power minus 34 into nu 0. So what will be the value of nu 0? Nu 0 is equal to this divided by 6.625 into 10 to the power minus 34. Okay. So that will be almost equal to 3 into 10 to the power 14. Just do it. That will be coming as almost equal to 3 into 10 to the power 14. And that will be your threshold frequency. Will you complete this? Did you understand it? That you tell me first. Okay. I hope you understood this particular concept and you can complete this numerical. The calculation part is I am not worried about. I am more worried about your conceptual part. Okay, so hope you understood what is photoelectric effect. Again I am repeating that, I am just recapping it, then I will give 2 more numericals to solve. What is photoelectric effect? The photoelectric effect is nothing but when some electromagnetic radiation of enough energy falls on a, this, all the words I am saying are very important, falls on a clean metal surface placed in vacuum, okay, the electricity is generated, means the electrons comes out from the surface of the metal and they start flowing. Okay, this particular phenomenon was observed by Einstein and is known as photoelectric effect. Fine. Now mathematically we can say that energy of the photon should be equal to the threshold energy, that means the minimum energy that is required to just take out the electron from the metal surface, plus the kinetic energy. So in mathematical way we can just write it down that E is equal to E0 plus kinetic energy, where E0 is known as what? E0 is known as threshold energy, or also it is also known as, what is that? Work function. We also call it work function. Okay. Now, if we just use the Planck's equation in this in this particular format of the equation, then what we will get? E is what? It's nothing but the energy of the photon, which can be represented by h nu. What is h? Planck's constant. What is nu? Nu is nothing but the frequency of the electromagnetic radiation. should be equal to 8 nu 0. Nu 0 is what we call it threshold frequency. What is threshold frequency? The minimum frequency that is responsible or that is required to take out the electron from the metal surface. Just take out the electron from the metal surface plus kinetic energy. So kinetic energy is what again? Kinetic energy is nothing but half mv square. So if that is required, we will use that particular equation also, half mv square. I am going to give two more equations where you have to use all the things. So please try to do that. Try to do that. I hope that 50% to 70% of you will be able to do that. And if you can't do, then please tell me. We will discuss it again next day. Okay, that is on Monday. Okay, but just now you write down the other two questions also. Right, second one. When EMR means the electromagnetic radiation of wavelength 300 nanometer falls on the surface of sodium metal, comma, the electrons are emitted with a kinetic energy. The electrons are emitted with a kinetic energy of 1.68 into 10 to the power 5 joule per mole. Please understand it and do it. Okay, just like that. You just don't do it mechanically. Read the question nicely, frame it, and then only you do it. Joule per mole. Next line you write number one. That's the first part of the question. Okay, what is the minimum energy? Needed to? What is the minimum energy needed to evolve an electron? What is the minimum energy needed to evolve an electron from sodium surface? Minimum amount of energy needed to evolve an electron from sodium surface. That's the first part of the question. So you have to find out threshold energy. That's the first part. And second part, part 2, number 2. What is the maximum wavelength? I told you there. Maximum wavelength means lambda 0. Okay, that is, if you get nu 0, lambda 0 is nothing but c by lambda 0. Nu 0 is nothing but c by lambda 0. Okay, what is the maximum wavelength that will cause a photoelectron to be emitted? And the last question, light of wavelength 5000 angstrom falls on a metal surface and the threshold energy of the metal is 1.9 electron volt. 1.9 electron volt. Find number one, the energy of photon. And number two, the kinetic energy of the kinetic energy of the photoelectrons. These questions you are going to solve and give me tomorrow. Okay, please